Okay, so let me go with one by one. So the points under the orchestration plane. VBON orchestrates the connectivity. VBON first point of authentication. VBON is deployed, and VBON, if it is the public deployment, we need a public IP address. In case on-prem deployment, it could be hosted on a data center or it could be hosted on the cloud-based places. But the IP reachability, so private IP address reachability to be provided to all the other component. We manage VBON must be reachable, and they should be permitted for TCP or UDP based secure connections, the dedicated port numbers. Similarly, VBond and other advantages, public IP addresses reachability or private IP reachability plus TCP UDP port number. So VBond IP, VBond port number should be permitted so that other components will talk to this device IP and then ports. Facilitates NAT traversal. If there is a situation that I have a campus and this campus is not having an direct internet access path, so these devices are behind the NAT. So WAN edges available with private IP configured and then NAT public IP. So this WAN edges, private IP address and public IP address both could be collected by VBON, because while the VPN tunnel is trying to set up from one WAN edge to the destination WAN edge, whether it is happening from public IP to public IP, or we can put one step ahead that from public IP address to private IP address. So public to public or private to private or private to public, in which manner the IPsec VPN tunnel is going to be established. So we have a certain classification in this place just to achieve the various types of VPN tunnel establishment. So VBond collects its unique private and then IP address for the devices. So IP addresses used for the authentication could be collected, and IP address could be like on the private path or on the public IP address path will be collected by the VBond. So facilitates NAT traversal. Other components need to know the VBON IP address or DNS information. So vSmart, vManage, Vanages, while we are configuring, we must provide the IP address of the VBON where it's going to talk, or fully qualified domain name after the DNS resolution. This is going to talk to the VBON. We don't configure Vanages with the vSmart IPs or vManage IP. We just configure only the VBond IP address. As I told you already, VBond authenticates and VBond distributes the controller information to Vanages. I think this is the next point. We can see it here. Authorizes all control connections, distributes lists of vSmart, and then vManage to all the vEdges. So authenticated devices will receive the information about available controllers and controller informations. So VBond orchestrator, first point of authentication, public IP, NAT IPs or private public IPs are collected from other devices, and other components are configured with the VBond IP, and authorizes the control connection. It's in a whitelisted design, distributes the controller information to authenticated devices. Okay, so we do have vSmart. vSmarts are the centralized brain of the solution. You can say like centralized control plane. vSmart establishes OMP pairing with advantages. Okay, so while we are introducing vSmart, so vSmart complete OMP adjacency with the data center, OMP adjacency with the campus, OMP adjacency with the branch, and then OMP adjacency with other devices. So it completes OMP pairing with other advantages, and they do act as root reflectors. vSmarts, they never sit in the data plane path. It's only for the control plane. So they are going to act as equivalent to BGP root reflectors, in the sense routes generated by home office devices will be received, and these routes will be distributed to other advantages. Data center again generated from them. Okay, so will be received by the root reflector. and from there they will be distributed to other device. So they do have the root reflectors role, and by establishing the session with other vantage devices, then routes will be propagated with each other. Additional like policy enforcement, service chaining, hub and spoke policy for partial and then full mesh topology building. Like most of the manual path manipulation procedures are controlled through the vSmart. Orchestrates secure data plane connectivity between edges. vSmart advertises the public or the transport IP addresses available on the devices. By distributing these IP addresses to other devices, it forms or it helps forming the IPsec VPN tunnel with other component. So OMP or vSmart is responsible for advertising the TLOC or the transport addresses. By advertising them, it builds the information that IPsec tunnels can be automated. We don't establish any IPsec VPN tunnel manually. We don't push any IPsec related informations to the devices. So automated VPN tunnels are triggered, and then automatic VPN tunnels are established between WAN edges. So vSmart or OMP is responsible for distributing the transport informations, transport IP information about the WAN edges. By distributing them, VPN tunnels are automated. So vSmart establishes neighborship with WAN edges, distributes the routing table information from WAN edge to WAN edge, and distributes the transport information so that VPN tunnels will be triggered. And OMP distributes the VPN security keys, like what encryption key is used for encryption and then the decryptions. So various routing table update will go out of them. One for the service VPNs, and the second will be for VPN tunnel establishment, and third one will be for the encryption key communications.
Parth, one question.
Yeah.
In any bad scenario, if two branch advertise the same route table, right? So what vSmart will do in that case? In
Again,
perfect.
yeah, vSmart vSmart will not do anything apart from then forwarding the information to the others. For example, if branch
So
one is advertising subnet X, and same subnet is advertised by the campus device X. So now vSmart will receive the subnet, and then next hop IP address is campus, and then receive the subnet of X, and then next hop IP address is a branch, and these two things will be forwarded to the data center or other devices. It doesn't do anything in middle. Just mean it just receives it and it forwards it. Now this data center's device decision that X subnet is behind with the first hop, I mean the campus device, and same subnet is available with the branch. So between X and then Y, then again path selection will go further, like X on this campus router or X on the branch. So which path is the best path? One path will be utilized. It's a wrong design, but still, if this situation comes in, obviously like one path will be selected and other path will be ignored by the other devices. So root reflector or a vSmart, it receives and it just forwards to others. Other routers will take their own decision based on the path selection or the best path selection algorithms. So WAN edge router leverages traditional routing protocols like OSPF and BGP. So one point I wanted to add for the data plane, that is WAN edge. While we are introducing the Vantage routers, this Vantage routers, still we can use the local routing protocol like OSPF. If it is CH, we can use EIGRP, or we can use even static routes and then BGP. So both IGPs and then EGPs are utilized to communicate with the LAN site, and with a fabric site, this is utilized with OMP. So WAN edges with vSmart, which is OMP routing protocol sessions, and then WAN edges to the LAN site, it goes with any IGP or even BGPs. Okay, so in physical form factor or virtual form factor, it happens in the same situation. So redistribution is a primary requirement here. So if I run OSPF to OMP redistribution, and to receive the routes from OMP to OSPF redistribution. EIGRP, EIGRP to OMP, and then OMP to EIGRP redistribution. So like what kind of classic LAN side routing protocol we try to use, and this routing protocol will be like redistributed into OMPs. So WAN edge router sits at the site. It has the level, it has the traditional routing protocol communications with towards the LAN site, and apply policies like if any ECL or any QoS configurations are applied, so they will be enforced towards the data. And OMP adjacency with the vSmart and provides secure data plane encrypted channel encrypted communication between the WAN edges in hardware platform or software platform they are supported. Okay. So management plan as a,
Pratibhan, one question.
yeah,
Can
sure.
you please go back to the yeah? So we cannot build any pairing with our underlay, right?
No, we can do that because suppose I'm connecting my Vantage, this branch router with an MPLS. Though for SD-WAN this is Vantage, but for MPLS this is customer edge. And if the MPLS L3 VPN configurations to be applied here, so we need to take the MPLS interface on the branch and MPLS interface to be configured with MPLS provided IP address. And also I need to configure some CE routing protocol, maybe like OSPF or even BGP to be implemented. So we can run underlay routing protocol communication with the transport. Similarly, like traditional routing protocol communication towards the LAN side. But for the overlay communication, branches will have the OMP sessions. So this underlay routes or underlay, subnets, they will never be propagated into service VPN, and also these informations will not be propagated to vSmart. So underlay is isolated completely under a dedicated VRF with the ID of VPN 0. So we introduce VPN 0 or VRF 0, and this is going to be for the underlay communications, and then VPN 1 to 511 for service side, maybe towards the LAN side. So VPN 0, underlay static routing, underlay default routing, underlay dynamic routing protocol we introduce. But this VPN 0 routes will never get propagated into service side, or service side VPN routes, VPN 0 routes will not go into vSmart. We have a strict segmentation for this underlay and then overlay communications.
And can VEdge use those like VPN 0 to communicate with any other non SD-WAN migrated site?
Yes, it can. It uses it. Suppose I want to build an standard IPsec tunnel from Vantage, Cisco Vantage, SD-WAN Vantage device to a firewall which is available outside. We can be able to use for we can use it through VPN 0. So Vantage is Cisco SD-WAN communications path or non-Cisco SD-WAN communication path. It happens through VPN 0 port. So VPN 0 is a dedicated VPN connecting to the transport. All transport connections, all transport circuits are terminated in it. Dedicated IP, dedicated default route, dedicated DNS configuration, or whatever may be the transport related configurations to be applied, uniquely we can configure it.
Thank you.
One question from my side. Refer to the same question. So that means, I mean, in order to communicate with a non-SD-WAN migrated site, so this traffic flow will be part of the underlay fabric, right? It will not participate in the overlay fabric.
That's right. It is part of the underlay. It is part of the standard MPLS or the provided network.
Okay. And again, referring to same diagram, suppose we have two branch sites and connected to two different FPLS provider. So would it be possible to build a data plane IPsec tunnel between those branch sites, having connected
Yes,
to different FPLS
yes,
providers, and
yes.
how
You
the routing we are going to do? Yeah.
No, this is automated. As I told you, when branches are connected across MPLS, or branch one is connected, one device is on MPLS, one device is on the internet, or another branch connected both the interfaces into mobile network. Once the transport IP address becomes reachable with each other, irrespective of whether they are connected to 4G or MPLS or internet, I'm connecting one device on internet and then one device on 4G and one device on MPLS. Once the internet IP, MPLS IP, 4G IP, like once internet IP is reachable to this router and then this router, and 4G IP is reachable to MPLS and then internet, VPN tunnels will be automated. Because why I'm saying this particular point is like if the transport has a limitation, like internet is not having reachability to MPLS, then VPN tunnel cannot be established. MPLS has no reachability to 4G and then internet. Obviously, like we will not be able to build the VPN tunnel. So once the transport has a reachability with each other, and this transports like various transport and its inter VPN sessions can be built. So WAN edges can have formed the tunnel from 4G to MPLS and 4G to internet or vice versa. Any combination, the VPN tunnel can be built. So, but the transport provided IP addresses must be reachable and the dedicated TCP UDP port number to be reachable with each other.
So that means if we are having two different MPLS providers, so we need to do something in order to have this peering between the service provider, right? So that only
Yeah,
we can have this end-to-end reachability.
exactly. So
Yes, sir.
the providers, and we need to check that this provider has reachability to other provider and the public IP reachability to the destinations.
So can we use a underlay transport to have a connectivity with our vBond, vManage or vSmart?
Okay, underlay connectivity is used for the basically like the components connections. So what I mean to say, in this picture, I'm introducing vManage. So vManage has a VPN 0 deployed. And this VPN 0 has one transport interface. Though it's a virtual machine, we introduce one interface in VPN 0. vSmart, again virtual machine, it interface goes into VPN 0. vBond, when vBond comes in picture here, again it is available with VPN 0. So all the components are available with its VPN 0 interfaces. Even routers will have VPN 0 pointing to the transport. So VPN 0 interface underlay, basically connecting to the transport, VPN 0 interface on the underlay. So we use underlay interfaces and on VPN 0 to form the authentication or to form the control plane sessions or data plane sessions or whatever it may be. So underlay is a one which is used for the whitelisting and control plane and then data plane communications with this component. So we don't have any other VPN and we don't use any other thing. Service VPNs are supported only on the WAN edges.
Okay, but VPN zero transport can either be internet or MPLS or 4G.
Yes, that's what the benefit of here. So in vManage VPN 0, I have one interface in 4G. vSmart, I have one interface in VPN 0 of MPLS and controller, for example, vBond, VPN 0, one interface connecting to internet. But my transports are reachable with each other. That means one IP in VPN 0, one IP in VPN 0, one IP in VPN 0, they become reachable through the transport. Then they will be whitelisted and they will be authenticated and fabric will be provisioned.
And can I have multiple VPN zero interfaces on these vBond, vManage, and vSmart?
Yes, one only one VPN, only one VRF supported on the controller is VPN ID of 0 or VRF ID of 0. One device can have multiple, but the limitation here with the controllers, they do have one VPN 0 interface and one interface for management, that is VPN 512. But WAN edges, they have multiple options because WAN edges, one connection goes to MPLS, port number one, port number two goes to internet, port number three goes to 4G. So for WAN edges, multiple interfaces can be mapped with VPN 0, but as a VM limitation, we can use vManage or the vSmart or the vBond will be with one interface participating in VPN 0.
Okay,
Okay, right.
thank you. That's it.
Mhm.
I have one question. So between the branches, the IPsec tunnels are possible, right?
Yes,
Direct.
there are direct VPN tunnels. Only the thing is, if we think about BGP, eBGP scenario and IBGP scenario, we don't use eBGP scenario, we follow IBGP scenario. Just for your clarification, I'm using data center router, and I use this is my BGP router, and then a branch. There are three routers. So now when I'm connecting, these devices into the network and configuring BGP, so IBGP peering between the devices, and then IBGP peering between the devices. So now the benefit of IBGP, by default, one IBGP neighbor's route will be not propagated to another IBGP. Just to forward that, this should be configured with root reflector, and then other devices are configured as root reflector client and then root reflector client. Meaning that if a subnet is created, if the subnet is advertised by data center router with the next hop IP address of 1, and this data center BGP prefix, IBGP prefix will go to the root reflector, and this root reflector forwards directly here, and it doesn't change anything in the BGP attributes. That means in the branch, I can see the subnet is X, the next hop IP address is 1. That means for this branch, the next hop IP address to reach the subnet X is the data center router, not the root reflector. The routing table update is received from root reflector, but the next hop IP address is not the root reflector. The next hop IP address is the data center router. In the same way, I'm going to advertise some routes in the branch. For example, subnet Y, and then next hop IP address is 2, which is the local IP address. Though this is updated to root reflector, when this is forwarding to the data center, we can find the subnet is Y, and then next hop IP address is 2. Meaning that the control plane communication is happening via the root reflector. Any data to go from X subnet to Y, it's going here, and via the transport path, directly connected path, or via the transport path, data plane communication will go from data center to branch, and then data center to branch to data center. So control plane takes place via root reflector. Data plane is not going to go through the root reflector. Data plane is directly connected. The same logics will be followed in vSmart SD-WAN as well. So we introduce the home office devices, campus devices, vSmart, and then OMP. So we form OMP adjacency, OMP adjacency. Any route originated by here, next hop IP address would be this. The same next hop IP address will be propagated here. When this is configured as subnet A, the next hop IP address would be announced as same thing here. So this control plane communication will happen through vSmart, but data plane communication will happen from campus to home office or from data center WAN edges to the other WAN edges. So data plane communications are direct, and to send them, the data is sent over the VPN tunnel, IPsec VPN encryption, and then IPsec VPN decryption, encapsulation, and then decapsulation takes place. So data plane is direct between WAN edges. Control plane communication will happen through the vSmart.
So once two branch routers already learn subnet of each other, uh, even if the controller is not available, shouldn't they be able to communicate, continue to communicate?
No, no. As I told you already, if this device is retaining the connection with the vSmart, if he's retaining the connection with the vSmart, that means routers have only one option to receive the routing table update on from the vSmart. Okay, that means it can send the routing table update to vSmart. It can receive the routing table update from vSmart. In case vSmart goes down, no vSmarts are available for the adjacencies. In this case, what happened? It says, okay, no routing adjacency, no control plane is present. Only local subnets will be available in the VRF and then routing table. Local routing takes place. It will not send any data to outside the other devices. So at least one vSmart with the active control plane should be present. So another
So
5 minutes I will
Pratibha,
address, then we'll take a small break. Yeah, go ahead. Yeah.
Yeah. So vSmart only not only provide the subnet information, like exchange the subnet information, it provide additional information as well, like as you mentioned, T-log and their colors and their IP address information as well, right? If they don't have that IP address information, they will not able to communicate as well.
Right. Yeah. So vSmart will have five types of routing table update. Just to add a point, we will talk about this detail, but at this moment, first thing is routing table update, and the second thing is a T-log. So based on the T-log, VPN tunnel will be established, and then third one is IPsec encryption keys, the key which will be used for data encryption and then decryption, and also we try to make the policies. Well, we are creating centralized data policies, and when we are trying to create centralized control data policies, policy informations will go towards to it, plus the service function. In case L4, L7 devices are introduced, service insertion we try to do. Even this service insertion associated routing table update will go through vSmart. So vSmart exchanges the T-log, make sure that all WAN edges are forming the VPN tunnel with each other, and any data going from one router to another router, encryption. Again, data to be encrypted, and what key should be utilized. The key distribution takes place via the vSmart, and what subnets are allowed to talk with each other. Again, subnet information will go through routing table update. Plus additional management like policy enforcement equivalent to route map, or policy enforcement like L4, L7 services, vSmart comes in picture in middle. Okay, yeah.
One question from my side. I mean, there is a concept of graceful restart for OMP, right? So is
Yeah,
it
yeah,
some?
yeah.
Again, as Satya asked, so is it something we can relate this to? I mean, even if we lose the connectivity to controllers, then also, I mean, this data plane traffic will, I mean, data plane connection will be continue to be
No, no,
remain.
that is not related to this. I
Okay,
will explain it. What is graceful restart?
sure, sure, sure. Okay, no problem.
Okay.
Hi, I have one question. So, as you said, like once the branch will able to get the route reachability via control plane, till the time the branch having the routes, if even though control plane is not available, they will be able to communicate, right?
If they have local routes or statically defined routes, then they can talk with each other. But if OMP is down and routing built based on the dynamic entries, but if the control plane goes down, they won't talk. Static routes, and placing the static route into the VRF, which is permitted, so we can do it. Okay. Yeah.
In that case, I think if route is going down, right, actually at the
Mm.
branch, we will not be able to detect that, right? In OMP, if OMP, because it is, there may be some route updates, so it is keep.
No,
Uh,
we put it as a least condition, like by installing a default route into the VRF, and this is going to be with highest AD values. If OMP routes are installed, OMP routes will be preferred. In case OMP route is not available, then with the highest AD preference, then route static route will be called into the routing. Basically, routing will be enabled for it. So that is possible. Like standard routing protocol definition and then standard routing protocol configurations like AD or preferences, we can do it with OMP as well.
okay.
Okay, and all the three controller V Smart in one group, all are acting as a active.
Yes, all of them are active. Even they do have OMP adjacency with each other. So OMP is basically runs between vSmart to Vanages, and also run between vSmart. So in case an update goes into vSmart one, will be synchronized to other vSmart. So they will be like the synchronization between vSmart to vSmart, and also vSmart to other Vanages. within the group. So from one group to another group, if we want to propagate the route, we have a separate or additional config. By default, OMP sessions will not be from one group to another group, and manual configurations are needed so that routes will be going from one vSmart control plane group to another vSmart control plane group. So while we are configuring a vSmart and Vanages, we'll tell that this vSmart or this Vanage is placed into what controller group so that OMP adjacency will be initialized. vSmart goes into group ID 10, Vanages goes into group ID 10, then they form OMP adjacency. Suppose Vanage belong to a different group ID 20, then OMP adjacency will not be decent. So same group or controller group, vSmarts and Vanages will form the OMP adjacency, and also between vSmarts on the same group, OMP adjacency will be built.
Okay.
Okay. Yeah.
Um, so as you
Yeah.
said initially, we manage, we smart, we want, these are the virtualized platform, right? So let's say we smart have a as a virtualized platform in one group. By anyhow they are not available, right? One group is not available. So at the same time, do we have any synchronization with the other group so that the other group can be enabled at the same time to avoid any disconnection with other with the VHs or the data center communication?
Yeah, that is possible. So while we are configuring the Vanages into the controller group,
Mm.
primary controller group and the secondary controller group. In case a primary controller group is not with any smart, then it will talk to second controller group. Then OMP adjacency could be retained. So this is possible, like configuring primary and then secondary controller group ID at Vanages.
Okay.